Hi class, Mr. Nguyenhuu again. Today, I would like to show you how to solve for a rational equation. Please remember, last lesson we studied what is a rational equation. A rational equation is the kind of equation we have some unknown at the denominators, such as this. This is a perfect example of a rational equation. So today we'll learn how to solve for the unknown of a rational equation. I break it down into steps. If you want to solve for a rational equation, the very first step, you want to clear the denominator. So if you want to clear the denominator, so you have to multiply every single term of that equation by the LCD. But in order for you to identify the LCD, so we have to prime factorize all the denominators to simplest primes. So the first step, prime factorize all the denominators so you could be able to identify the LCD. And the second step, you want to clear all the denominators, so therefore we will multiply each term of the equation by the LCD. So we divide all the denominators out. We clear them all out. And then the next step, before solving for the unknown, we have to define the domain of the equation. Let me clarify a bit. What is the domain of a rational equation? The domain of the rational equation is a set of all real numbers, excluding those numbers that make the denominator 0. Imagine if we replace x by -2 in here. -2 plus 2, which is 0, and the numerator is 2 over 0. That is undefined. So therefore, I just want to say if one of the solutions of the equation happened to be -2, the entire thing would be undefined. So before solving for the unknown, we have to define the domain of the equation. And once again, a domain of the rational equation is all possible real numbers, excluding those that make the denominator 0. And after we define the domain of a particular rational equation, and then we continue on to solve for the unknown. And after you get down to the solutions or a solution of the equation, to want to make sure that the solution would not make the denominator 0. And if it's not, that is a good solution. If it makes one of these denominator 0, then we call it extraneous. So we will exclude it from the set of the solution. Okay, now we go ahead and solve for the rational equation. I am going to go on the first step, prime factorize all the denominator. So you ask yourself, okay, can I factor this? Since x plus 2 has no GCF, that is a prime. Then can I factor x minus 2? No, another prime. But can I factor x squared minus 4? Yes, this is actually a squared minus b squared, so I am going to factor it out as x plus 2, x minus 2. And after I prime factorize all the denominator, I have to identify the LCD. This is the first step. The LCD is x plus 2, x minus 2. That is the series of primes put together by multiplication, such that this series will divide all the denominators evenly. Okay? And the second step, I am going to multiply every single term of my equation by the LCD, in this case, x plus 2, x minus 2. Same, x plus 2, x minus 2. X plus 2, x minus 2. The first term, we divide x plus 2 out. I have x times x minus 2 left. X times x minus 2. The second term, I divide out x minus 2. I have negative 1 times x plus 2. The last term, I divide out x plus 2. I divide out x minus 2. One time, I have 8 left. So after I clear all the denominators, I end up with a very nice looking equation right here. And we do know how to solve for this. We distribute the x in, we distribute the negative 1 in, and we combine all the like terms, and we check to see if we can solve for the unknown. Now, before solving for the unknown, I go to step number 3. I have to define the domain of the equation. You look at the equation. We look at the denominator of the first term, x plus 2. So clearly, if you replace x by negative 2, negative 2 plus 2 would be 0. So negative 2 would make the first denominator 0. And then you move on to the second term. If you replace x by 2, and 2 would make the second denominator 0. And the last term, we have two factors, x plus 2 times x minus 2. So either minus 2 or plus 2 would make the denominator of the third term 0. So therefore, the domain of this equation, as I mentioned earlier, is a set of all possible real numbers, excluding those that make the denominators 0. In this case, two numbers, 2 or negative 2. And then solve. X times x is x squared. X times negative 2 is negative 2x. Negative times x is negative x. Negative times 2 is negative 2 equals 8. Combine like terms. X squared minus 3x minus 2 equals 8. And then we notice this is a nonlinear equation. If we want to solve for a nonlinear equation, we have to make sure that we rearrange all terms in descending order of the exponent. In this case, we still have the number here, 8. On this side of the equation, you want to bring it over. You want to minus 8 to both sides of the equation, so you want to have 0 here, and you have x squared minus 3x, negative 2. Take away 8 is negative 10. That is the simplest form of a trinomial. And we set it equal to 0, and we solve by 0 factor property. I factor, I have x minus 5, x plus 2 equals 0, and then we continue to solve, and we say that this quantity times this quantity equals 0, then either x minus 5 equals 0 or x plus 2 equals 0. And then you solve for the first equation. The unknown is 5, x equals 5, or you subtract 2. The second equation we solved, the unknown now is negative 2. Okay? And after you solve for the solutions, you have to check to see if any of those solutions happen to be the one that makes the denominator 0, then you have to throw it out. In this case, x equals 5 is good. X equals negative 2. We already say that the domain of this equation could be all real numbers, but 2 or negative 2. So therefore, this is no good. This is extraneous solution. Even though we end up with two solutions, but we only pick the good one. In this case, 5 is a good one. So the solution of this rational equation is x equals 5. And x equals negative 2 is extraneous.